Morning, I'm Eriochrome, Department of Chemistry. Today I'm going to talk about on the topic of a DT-based thinking of concept of a estimation of hardness in water sample by EDTA. So the estimating the water sample is a main source in this purpose of an environmental issues based on this pollution controls. So the pH of the water pollutions can be controlled by using the formation of a hardness of the samples. So there are so many waters can be improved by using this industrial water, groundwater, seawater, and the drainage water, sewage water, and the mixed industrial purpose water, and distilled water with a grade 1, 2, and 3. In the variations of the pH level, that is of 1 to 14 with the pH level, it can be carried out in the formations of the sample analysis by using the form of EDTA solutions. So what is the built solution we are using in this estimate? EDTA for ethylenediaminetetraacetic acid. So this is the formula for converting the basic to analyze the water samples. We are getting only the neural solution, which is nothing but this one EDTA. And what is the pure solution?
Standard water.
Standard hard water. So here we are using as a standard hard water as a first analysis of titration method. And with the second titration method, we can use it as of standard normal water. And the titration we can use it out for the tap water. So whether the three variations of the liquid solutions can be carried out and can be using in the form of analysis. And what is the additional solution we are using this? 5 ml of ammonia buffer. So buffer which will react with this reaction into this acid and the base reaction in the reaction process to convert as a buffer. And what is the indicator we are adding? Eriochrome Black T. So Eriochrome Black T to indicate the end part of the reactions, how the color can be created by using the form of pink to with the deep blue color. So this is our reaction temperature. And what's the temperature we maintain to display this experiment? Room temperature is enough to control this temperature to do this process. So here we are converting the step 1 process as purpose water or sewage water. We are first analyze and centrifuge the water by using the form of material, and we have to collect the sample analysis from the upper layer to the lower layer. By using the centrifuge in the material, the lower layers can be deposited by using the form of waste products can be removed in the form of film papers. And by using the upper layer of the water, we are collecting from this layer water, and we have to add this solution as an additional solution of the ammonia buffer, and the indicator we are using as an EDTA indicator. By the titration with this solution to the pure solution of EDTA, we are getting the pink color of by adding this ammonia and the EDTA indicator. With this titration again with this pure solution, the pink changes to the deep blue color. So this is the point how the solutions can be carried out. Can the ammonia is evaporated by using in the form of a complex analysis. So that here the complex formed by using the form of we are adding the ammonia and then the EDTA indicator. And this color, reddish color, which is color given by this the complex by using this pure solution from the EDTA. The EDTA plays a major role how the analysis of water can be standard level with the pH of the 0 to 14 level. So this is the first titration how the values can be carried out by using the next to conclude with the concordant value. By the titration 2, we are adding as a same with this pure solution as the EDTA, and with this liquid solution we are taking as a boiled water. So boiled water already we have boiled the water at 0 to 100 degrees Celsius, and the evaporations can be carried out by using the formation of all minerals and elements. So the water is contained with this pH level of 1. So from this process, again we are adding the actual solution as an ammonia buffer and this liquid solution, and again with this EDTA indicator, it gives a reddish to dissipate, and the color from the wine red to sea blue color is the point how the reactions can be carried out through this process. Likewise, again we have repeating the third type of titrations, that is with the tap water. So tap water already we have the more content of the chloride. So we have the NaCl content so that it will react faster than the hard water and the boiled water, because it does not form a layer formation. It has more form of a chloride content, and by using this shape of with the ammonia buffer and the EDTA indicator, it will react with this wine related to the steel blue color reactions. So whenever we have this type of reactions can be carried out the same component value to create the values related to this pH level. So overall, the calculations can be carried out for the total hardness of the water samples and the combined hardness of the water sample. And by these two calculating this, we will get the total hardness of the water sample in this by the titration of 1, 2, and 3. So by the formula we are entering in this is that is V1 and 1 by V2. V1 can be calculated as by the titration 1 of calculating of calcium carbide value. The elements present in this total hardness is calcium, magnesium, and the carbonates. So these type of the elements they are used in this EDTA experiments. Thank you.